All right, everyone, be sure you have your worksheet and something to write with. So as you watch this, you can take some notes and fill in the questions.
Broken bat looper down the left field line. Tough play. Elvis Beltre going over it.
All right, now that you have seen all the little metaphors of what a cold front could be, answer the first two questions, which is what would be the best video clip that you saw that represents a cold front and why? And then the other question, number two, would be based off of your videos and using your own little logic, would you say that a cumulonimbus cloud, which is the cloud that's part of a cold front, has a lot or a little turbulence? And then which video probably demonstrates that the best? All right, so now question number three, when you examine this diagram, you notice that the cold air is pushing up underneath the warm air, causing that warm air to rise, and then while it rises, it's full of a lot of humidity, water vapor, and then it forms these giant clouds. So the question is, what do you think one reason that the cold air mass is more dense? What is it about the cold air that potentially has less water vapor? Because we know if it's a higher pressure, then it's going to be carrying less water vapor. So between this diagram and the last diagram, you can see that these cumulonimbus clouds are huge. They stack way, way high up into the sky, about to the top of the troposphere. So the question is, for number four, is why does that even happen? What causes these clouds to be so much bigger because of the front type than any of the other front boundaries that we've looked at in yesterday's class? So looking at this third diagram, you can see this is a bit of a graph, and across the bottom you see a temperature range in Celsius, where on the far right it's up to 60 degrees, and on the far left it's minus 100 degrees Celsius. 100 degrees Celsius, that's minus 148 degrees Fahrenheit, so obviously it gets pretty cold. And then as you look up, you see the different layers of the atmosphere. So knowing that we have our weather existing only in the troposphere, if you kind of track that line as it goes up, the temperature gets colder. So the questions are based off of looking at this diagram and then looking at the previous diagram, knowing just how high the clouds stack within the total troposphere. So try to do your best to answer the questions as follows.